Hi, my learners. Right, today we are going to introduce ourselves into the other type of equation, following the exponential equation we have had in the previous videos. So we need to understand what it is all about what we have here today. That's the logarithmic that's the equations. Right. Remember, the topic is about the exponential and logarithmic equation. As I indicated that we don't need to discuss both at the same time to avoid some confusion. So we're taking it parts by parts. So we have had the issues about the exponential equations. Now let us concentrate on what we call it the logarithmic equations. Right, firstly, let's define what a logarithm is all about. Logarithm of a number, what it is. Remember what we're discussing about the numbers, number throughout, where we're converting the numbers to different powers, which call them exponents, something like that. But now, let's first of all get to know what it is about the logarithm of a number. Once we've understood what logarithm is, then we are going to introduce ourselves into what we call the logarithmic equation. Like previously, this is what we had. Remember, I introduced into a process of presenting numbers in factor form. Like say, for example, 81. We had 81 expressed in the factors of 3. So like here, 81, if we express 81 factors of 3, we talk of how many 3s to be multiplied to get 81. We talk of 4 3s. So it would be like 3 times 3 times 3 times what? Times 3. And the end of the story, we said this is simply presented in short form as 81 is equal to 3 to the power 4. Right. So, and at the very end, we really concluded that such type of presentation of an equation, this kind is what is known as an exponential equation. So that yourself, you can model it out to say, whatever we have above the exponential equation, this is as good as presenting the 81 by any other variable of your choice, like say y, and also you talk of v3, which in this case is a base. You presented that one by maybe talk over x, while a 4 is represented by a certain variable like a t, like that. So that presentation is what we call that's the exponential equation. Right. So let us now try again to understand the numbers here. A 4, which in this case is a t, and a 3, which in this case is x, and a 1 in this case is y. We said that this top number here, written on top of a 3, in this case talk of a t, written on top of x. This one tells us how many times are you going to multiply a factor down here, this number down here, in order to get this one. That's the meaning of this. Well, this number here, or this variable here, which in this case here is a number 3, this one gives us a relation between itself and 81. This one is a factor, something that can divide into 81. So in this case, it means x can get into y. That's the thing. Any number represented by x can get into y. That one is a factor. Right. And this one is defined as an exponent. This one is divided as the base. And this is the number under consideration. So if above the logarithm of a number is targeting this here, exponent, the one previously we defined as exponent. In this case, it's a 4. A 4 tells us how many times I multiply a 3 to get 81. This number, the one we call the exponent, is the one that is defined as what? Logarithm. Right. So I've made it very simple here for you to understand and get to know what a logarithm is all about. Don't just memorize it. Hey, logarithms, this is the way we solve logarithm. No. Try at first of all to understand. When we say a logarithm, what is a logarithm? So logarithm is just a number that tells you how many times are you going to multiply a factor of a particular number in order to get that number itself. Like here, this is the number 4. It tells us how many times do I multiply a 3 in order to get what? 81. So we say logarithm of 81 in this case, when 81 is expressed in factors of 3 is what? A 4. Right. So it means the logarithm of a number depends on the factor that you put under consideration. 81 itself can be expressed in factors of 9. So I've got 9. How many 9s do you multiply to get 81? You talk of 2 9s. So it means that 2 should be written what? On top like that. So in this case, 2 tells us how many times do I multiply 9 in order to get 81. So here in this case, logarithm of 81 is not a 4. You see? Now logarithm of 81 is what? Is a 2. Because you have expressed 81 in factors of 9. You talk of 9 times 9. So here we say logarithm of 81 is what? 2. If 81 is expressed in factors of what? 9. So you say logarithm of 81 in factors of 9 is a 2. So a 2 on top, or in short, the exponent, is the one that is referred to as logarithm of a number. Right. So as such type of presentation may take us into what we call them as logarithmic equation. So now look at this. When we say 81 is equal to 3 to the power 4, just like an example, counter example, and we, from what we have discussed, this is an exponent, and we say 4 is the logarithm of 81 if it expressed in factors of 3. How do we state that one out? What we say is like what I said there. I'll write in the board to say logarithm of 81 in factors of 3. But now this number down which goes the factor, we have our own definition of it, and that number is defined as what? As a base. So in this case, I'll not be talking about a factor, but now we'll talk of a base 9, base what? 3 in this case. So if I'm going to explain this one out, this statement here, which is the exponential equation, I can state it out to say logarithm of 81, that's in base 3, simply meaning that if 81 is expressed in factors of 3, is what? That's what? A 4. Think that if 81 is expressed in factors of 3, how many 3s do we need to multiply in order to get 81? So you talk of 4 3s to be multiplied to get 81. So the statement produced, we say logarithm of 81 in base 3 is a 4. Briefly, as mathematicians, we come in then now to light like this in short form. In short form, or say in brief, the statement we have here, this one here, is simply written as, instead of writing logarithm of 81, we simply write log of what? 81. Write 81 just like less a bit, and then in factors of 3, that's the in base 3, that base is written down here like this. Right. How many 81s do we multiply? Sorry, how many 3s do we multiply to get 81? So how it stands there, logarithm of 81 in base 3 is 4. So what do you do here? You write a 4 on that side. Right. So log in brief, don't write, don't state a logarithm. I just say log of 81 to base 3 is equal to a 4. Right. So you can also see that there's some kind of relationship that is there between the two types of equation. This equation here, log of 81 to base 3 is 4, is what is defined as what? A logarithmic equation. It tells us the relationship that is there amongst the 3 numbers here. This gets into this one. Sorry, this one is the factor of this one. This one gets into that one. How many times? It gives us a 4. So this presentation is known as the logarithmic equation, and this one we already defined it as what? An exponential equation. Such that at the very end, I may have a presentation of like the first that I have there, the form of say y is equal to talk over m to the power x as an exponential equation, which means in this case my logarithmic equation will be like logarithm of y to base m is equal to what? X as such. as we have here to say 81 is equal to 3 to the power 4 is as good as writing now log of 81. Look at the position of 81 when you write the statement by this equation. Comes on top there. 3 at the base comes down here. Why number of times? How many times does 3 get into 81? 4 times is written on that side here. Is written on this side here. Why in this case the 4 is written on top like that. So there's some kind of a relationship that exists between the two types of equation, exponential and the logarithmic. Right. So this kind of equations are logarithmic. These kinds are what? Exponential. You have to understand that one out. Right. So that's the way we can introduce logarithmic equation. So you should be able to see the position of the number in relation to what we have in the exponential. The exponential is a number there, but here now we have to write it. You don't have to write a 4 here, where 4 means the number of times you multiply the 3 should not come here. Right. That's not the standard, the way we write these values when we are presenting them in the form of logarithmic equation. Right. But also again, this is the way we present up the numbers when we are trying to define issues about the meaning of the values in the exponential equation. 4 on top, not 4 down, 3 up there, then it means a different story all along. Right. So this is way we can introduce the logarithmic equation. So now what I want us to do is just like first, let's try to discuss on how best we can convert the equations from one form to the other. Let's say suppose you are given the exponential equation. How do we come up with the logarithmic equation of which, and sometimes we are given up the logarithmic equation. How to come up with the exponential equation of which? Right, so what I have here on the table, on the board here, it's like a table of some kind where I need us to fill. It has got 2 columns. One column talks about the exponential, another one talks about the logarithmic. So where we have got a gap, we need to discuss it. How can we fill that gap? Right, so here we are. This side here, we have got exponential equations. This side here, the other side has got, that's a logarithmic equations. Right. So, like say for example, the first equation here, let me produce some laws. Like that. I'll have here the first one is exponential, talk over m is equal to h to the power f. And somewhere here I have got log of t. That's it to base p is equal to n. And somewhere here I've got 16 is equal to 4th power 2, and here I've got talk over logarithm of what's out there to base 10 is 3. We are trying to see the relationship between the two types of equations, yeah? Exponential, logarithmic. So it's more like from what I indicated that every time we need to talk about the exponential equation, talk about the logarithmic equation. You'll be able to understand from what we have just discussed that say logarithmic equation goes hand in hand with the exponential equation. It means just like the basis of the logarithmic equation is exponential equation. So here you should be then in the position as a student to convert any one of them into the other. If I'm given the exponential, what would be the logarithmic of which? If I'm given the logarithmic, what would be the exponential of which? Things like that. So here, let's see. First part, we have got the exponential equation as m is equal to h to the power f. If you can be able to notice in this case, from what I indicated, you'll be able to realize that, say, this f, a number, just like a variable, on top of another variable, it has to tell us how many times do we multiply this variable down here in order to get m. So this must be a logarithm of m, in factors of what? H. As such, if I would like to fill this gap here, I'll have the logarithmic equation of this exponential equation as this. Look at this. It will be log of m. You see, m comes more like up there, which is the number you have at hand. What are the factors you'd like to express that m? I would like to express m in factors of what? H. So you write h down there. It's more like when h gets into m, what is the solution to it? So you find that in this case, it means the value of what? When you divide m by h, this one, it gives you what? F as such. So it means just like you multiply this h f times in order to get what? M. As such, logarithm of m to base h is equal to f. That is the logarithmic equation of the exponential equation m is equal to h to the power f. So what is there? Just a matter of understanding the way those letters have been presented. They have got a meaning. A letter on top of the other one that tells you the number of times you multiply, a letter down there to get the other one. Right, so m is here, it means m with the logarithm is up there. H there, it means h now is down here. While you talk of f here, now it becomes like a story. That's the solution to it. The same way, when you look at this one, log t to base p is equal to n. That also has got a meaning. The meaning of those variables, according to their respective position, will be able to help you come up with the appropriate what? Exponential equation of that logarithmic. So you come and first of all to try to understand the presentation of those variables according to position. So t here is just like on top of a p. That t, it means it's a number under consideration. So it means in this case you are trying to have a t here as such, and you'll be able to see like say t has got t is related with p and n. Fine. Now, what is the meaning of p in this case? And what is the meaning of n in this case? So p here, down here, down variable that is down on the lower part here. This p, according to this position, it tells you that that p is a factor of what? Of a t. So that when you have got this p here, being a factor of a t, so it tells you that p can get into t. How many times? That is what? 8 times. Right. So in this case, when you are going to write an equation here, which is exponential, you have to tell us, let's say, t, if it is expressed in factors of p, how many times do you get what? How many times do we multiply a p to get a t? So it means you talk of what? Any times. Is the times when we are going to multiply a p in order to get a t. So it means this n should be on top of a p. So it means here you have got p to the power n as such. The same it follows for this one. 16 is equal to 4 to the power 2. 2 is the exponent, is an exponent. It tells you how many times you multiply 4 to get 16. So in this case, it means this 2 is a logarithm of what? Of a 16. It tells you number of times you multiply the factor of 16. So how do you write there? You write logarithm of 16 to base 4 is 2. Right. And then finally here, it means this 1000 comes in just like a number, like that. Which can be written as equal to 10 raised to the power 3. A 10 is the factor of 1000. 10 gets into 1000 3 times. So you have to write the 10 with a power of the 3 as such. So try at least to be able to come up with the relation that exists between the exponential and logarithmic. Have the exponential equation, try to convert them into the logarithmic. Have the logarithmic equation, convert them into the what? Exponential equation. As such, if we need now to solve, that's the logarithmic equation. The procedure of which is simply stipulated here. Somebody asks you, can you solve the logarithmic equation? You can't even fail here. So what you should do there is just a matter of converting that logarithmic equation into what? Exponential. Simple as that one. Because we know that you already know how to solve the what? Exponential equation as such. So if I take you through, you'll be able to at least apply this procedure of solving the logarithmic equation by just converting or expressing the logarithmic equations into what? Exponential equation. Right. Once you express the logarithmic equation to exponential equation, then you have got exponential itself, which you already know how to solve it. So how do you solve exponential? Expressing stems to the same basis. So let me just have an example that should cover up this one. Say exactly when I highlight this one, what does that mean? When you talk of issue about solving the logarithmic equation, expressing to exponential equations, how would that help us? So here is an example. We simply have to solve this one. So for x, log of 64 the base 4 is 8, is x, only 2, and the log of what? 81 to base 3 is equal to x. Just that. Solving logarithmic equations. How do we solve logarithmic equations? That's what we have here. So here we're saying expressing the logarithmic equation to what? Exponential equation. So I have got two examples here that will help us to understand this statement out here. Right. So like the first one here, we have a log of 64 to base 4 is equal to x. Now, by the table that we have just had, you'll be able to notice that this is a logarithmic equation. So you will be able to define the terms and variables within that. You'll be able to see that this 64 is the number under consideration, but this 4 here, always at this position. Last tell you this one must be a factor of what? 64. It's more like how many times do we multiply a 4 to get 64? That is x times. Right. So x is the logarithm of 64 in factors of 4. So if you had to express this one to exponential equation by this guiding statement here, it'd be like you write your 64 like that, and then it'd be like how many times do you multiply a 4? So it means whatever number of times, that must be an exponent of a 4. So since this x tells you how many times you multiply a 4 to get 64, it means this x must be an exponent of what? A 4. So here you write 64 as equal to 4 raised to the power what? X as such. Right. So this is the logarithmic which has now been expressed into what? Exponential equation. So that now I know how to solve the exponential equation, there I will not have trouble. What I'll do, I'll follow the same procedure of solving the same of the exponential equation of h. So we said express them to the same basis. That's the thing. If you fail, you again go and follow the other procedure that we indicated earlier. Say convert the terms to the same exponent, or else you can have a different one, base or along. So here the base is 4. If you look at 64 here, you find that 64 can be expressed to base the 4. So just like how many 4s do we multiply to get 64? So you find that we have got 3 4s to be multiplied to get 64. Right, then this is equal to 4 to the power x aside. So base the 4, base the 4, what we expect that the exponent also to be the same. Then you conclude that say 3 is equal to what? X aside. So it means the value of what? That is a x in this case is equal to a 3. Last one, that is b. we have logarithm of 81 to base 3 is x. The same thing, logarithmic equation. How do I solve it? The statement says express the logarithmic into exponential. So if you are good at that, then this is not a problem at all. So what we have here, exponential equation of this logarithmic, it will be let's say 81 is equal to 3 raised to the power x. At the end of the story, what do we have? We have got 81 here, which we need to express this to base what? To base 3. So it's more like how many times do we multiply a 3 to get 81? You talk of 4 times. So here you write a 3, the power 4 is equal to 3, the power x, and then conclude that say x is what? Is a 4. So that's the way it goes. Right, so nice interaction. I'm happy we have been together, and hope that whatever is written on the board, like the video, you are able to take them down. Right, so all the examples, please try to go through them so that at the very end you have to really get the skill that we are trying to instill in your mind here. Right, so solve all the examples now and again, and back play the videos for you to master the concept, because some of us cannot get the things at the same time. So you need at least to back play the videos until you get the knowledge that is underlining the discussions in here. Right, so now before I leave, I'll still more give you one, if not two, a problem that you can be able to work upon on your own. These are not difficult. I'll need you to work out for the value of x here. A log of 343 to base x is equal to 3. B log of 3x squared base 16 is equal to 4. Right, can you work out on that one? So that the next meeting, we need at least to focus on the laws of logarithm. That now we know what a logarithmic equation is, and also we know how to solve the logarithmic equation by that statement that they given you, and this is the way it has been done. Right, but I wish you all the best in your studies. Please don't forget always this time you study the maths, the videos have always to be you. By data, if anything you are using smartphone, those who have got maybe at least access to the internet, have got PC, try to please watch this video now and again so that you have to master the knowledge. Where you have got no teacher, at least this save a story for revision. Please take it serious. Thank you very much.